everyone. My name is Matt Bichelle. I am Head of Product Marketing here at Aerospike, and it's my pleasure to welcome you to this session, Enabling the World to Search by Meeting with ZIR AI and Aerospike. I'm always impressed with our customers and what they're doing with Aerospike, and I'm also always very pleased to meet and speak from our customers. And Dr. Awadallah is the CEO and co-founder of ZIR AI, and he previously served as the VP of DevRel at Google Cloud. And prior to joining Google in 2019, he co-founded Cloudera in 2008 as global CTO, where he spent over a decade working with enterprises on ingest and extract work with big data, where he coined the concept of schema on read versus schema on write. He also worked as VP of Product Intelligence Engineering at Yahoo, and Amr joined Yahoo after his first startup was acquired at Tivia. He received his PhD in EE from Stanford University and his bachelor's and master's from Cairo University, Egypt. So without further ado, Amr, I look forward to the session with you.
Thanks, Matt, for the very pleasant introduction, and happy May 4th to all of you. I'll be doing a couple of things in my talk today. I will first sharing with you what ZIR does, so that you know a little bit about us. But then in the second half of the talk, I will explain to you how we use Aerospike as part of our infrastructure. So first, I have this number I would like to show to you, and I would like you to think, what is this number? Like, there's a meaning in my head, there's a concept in my head that correlates with this number, and I'm hoping you can read that concept from inside of my head without me telling you and figure out what is this number. I'm going to give you like 5 seconds to do that. Of course, that's almost impossible to do. Maybe one day, if Elon Musk figures out the neural link thing, where we have this chip plugged in directly to our neural network in our brains, maybe you'll be able to read what's in my brain. But until then, the only way of me getting that idea to you is for me to say these words out of my mouth that go from my mouth to your ear, and then your brain actually translates the words into the concept, the meaning that matches my meaning. And I refer to language, the way we speak languages, as the most unstandardized communication protocol in the world, because this is the number of languages in the world. We have more than 6,543 languages in the world today. I'm going to be talking more about language and why that's important later on, but the key message of this slide is language is a means to an end. It's not the end. The end results that I want to get for myself to you is a meaning or a concept in my head, and language is simply the conduit that we use to communicate that. So with that said, when we're looking for information today, most of us use what's called keyword search to try and find information. And when we're searching by keywords from a given language, we have a number of problems that take place, as you can see in this slide. The first problem that we have is just lack of comprehension. Keyword search does not take into account the order of words. For example, man kills bull is very different meaning than bull kills man. Multiple meanings of the same word is not taken into account, or multiple words with the same meaning is also not taken into account. So, for example, arm got injured should match hand and elbow were wounded. Wounded is another meaning of injured. Hand and elbow are not really another meaning of arm, but they are related. And in fact, they're part of whole. They're both parts of the arm. Last but not least, there's just general knowledge and pragmatics of the language. For example, if you search for Oleg lead invention, the keyword lead here can be taken into account as the past tense of lead. So a layman person who's not very knowledgeable, or a layman search engine that's not very knowledgeable, would think that you're looking for some random guy called Oleg that was leading invention in some company. But if you are knowledgeable, you would know that Oleg is actually the inventor of the LED, LED, the light emitting diode, which is the flash in your phones. And that's really the intention here, is looking for the person who invented the light emitting diode, and more about that. Next is one trick to try and improve keyword search is a trick that Google introduced about 30 years ago now, which is called PageRank. And the PageRank tries to look at how many people are pointing into your content with the keywords that you're looking for in the anchor text. in a sense, they're voting for your page. You're saying your page is really good, like Aerospike, excellent database, excellent database, excellent database. And then you get all of these anchor text pointing to Aerospike's website saying that, then Google would say, okay, that means you probably are a good result for that type of keyword. And that has been working back then, 30 years ago, when there wasn't that much content on the internet. But now we have so much content, we have so much interests from different people that's not working anymore. And in fact, not only that, the SEO spammers, the search engine optimization spammers, are spamming these tail terms and trying to get the wrong results to show up to make money from you. 90% of the search queries being issued today by uniqueness of search terms is what we call tail terms, not head terms. Last but not least, keyword search does not work across languages, which highlights this point I was making on the earlier slide of that being an unstandardized protocol for finding content. For example, if I search for how to cook a paella, as you know, paella is a very famous Spanish-Portuguese dish. If I search in English how to cook a paella, I'm going to get a web result from some random cook in the US or Canada or maybe Australia written in English about the paella. I'm not going to get the original recipe written by maybe one of the descendants of the inventor of the paella in Spanish or Portuguese. I'm not going to get that because it's written in Spanish or Portuguese. So that's kind of the defects with keyword search. Now, many companies, when they use standard search engines like Elastic or Algolia, or there's a number of others out there that do keyword search, they try to invest a lot in what's called a knowledge graph that augments the search engine, that has all the aliases of a given word, has all different meanings, has all these part of whole relationships that arm and elbow are part of the, hand and elbow are part of the arm, and Palo Alto is part of the Bay Area, etc., etc. And you can see how the cost of that just keeps going up. Like if you want to increase your quality, you have to increase the size of the knowledge graph, which means you now have a lot more development cost and maintainability costs of that knowledge graph. And forget about it if you want to do that across languages. It becomes extremely cost prohibitive to do. So what ZIR has built, and we'll show you a quick demo right now. Matt, please get ready to show the demo, is a neural rank technique, which digests all the knowledge and the languages of the world and creates a unified neural semantic representation that allows you to search across all languages with very, very high relevance and comprehension of that language. In other words, neural rank enables computers to map knowledge into a universal data brain that truly understands the essence of what we seek while removing language as a barrier to finding information. So Matt, please go ahead and run the video.
Just need to remind people to refresh their screen and rejoin audio as I press play. So go ahead and do that, and I'll press play in 3, 2, and 1. This is the product page for a Wi-Fi router on Amazon. I'm searching the customer reviews for can I stop my kids from accessing the web? And you can see that Amazon here is doing keyword matching, just like almost everybody else does, and the results are completely irrelevant to the essence or the meaning for what I'm after. Now compare that to our search engine where we indexed the same content. And I'm searching for, can I stop my kids from accessing the web? And look at this result. There is no way to block social time wasting sites at night for your children's devices. There is no keyword overlap between this query up here and the result you're getting down here, yet it's a perfect match because our engine is matching by meaning. Furthermore, our engine abstracts out language. So if I were to translate this from English to Chinese, take the Chinese query and search by that instead, you will see that we're still getting appropriate results because the language is being converted to meaning and we're matching meaning against meaning.
Thanks, Matt. So as you folks saw in that very quick demo, essentially the engine is truly matching by understanding what you're looking for, the essence, not the words. It actually throws away the words, it throws away the language, and it gets to the point, like what are you after? What's the concept in your head that you're after? And it matches based on that. And that has two benefits. One is way better results because now it's really matching the intention of the query and not just the keywords in it. And second, it actually removes language completely as a barrier to seeking knowledge. So regardless of what language you're using to query or which language the document is written in, you're still going to get the most relevant result. So that's kind of the beauty of the technique that we have, that we deliver as a software as a service to our customers. So next, why did this not happen before? And the reason why is because we actually, as a human civilization, we didn't know how to do this. Up to 2010, the best of the best techniques out there could only do this, meaning understand language at the level of like humans, could only do it at the level of a 7-year-old. Like the best of the best techniques until 2010, across all of our collective powers as humans, the best neural networks we could build, the best processing we could build, could understand at the level of 7-year-old. And then 3 very key events took place over the 2010s, which advanced our ability significantly to be able to comprehend at the level of adult humans. And that's what I'm going to go over right now. So first, before these new techniques were introduced, these 3 key events that advanced our comprehension ability, what we used to do is what's called sparse one-hot vectors. That's where we'll take all words in the language, like king and queen, and for each word, we'll have a vector like this, and one of the bits in that vector will be 1, matching that word. So the king will have 1 in one position, the queen will have 1 in another position. And you can tell right away, like, this is totally losing the context that king and queen are related. Like, it's not showing at all in this one hot vector. And that indeed was the first event. The first event was in 2013, saying one hot vector is bad. We should not be doing that. Instead, we should be doing full word vector, full multi-dimensional word vector. By the way, it's not 3-dimensional. I'm showing you a 3-dimensional picture here, so our brains can understand it because we think better in 3 dimensions. So if I look at the sphere on the right here, you will see these 2 red dots. These 2 red dots could be the queen and king mapped in that multi-dimensional, in that 3-dimensional vector space. And the neural network tries to put king and queen as close as possible together in that multi-dimensional space because they are very related in meaning to each other. And it will consistently be able to do that by just looking and reading through our text without any supervised information. So it's completely unsupervised. By being trained on top of massive amounts of text, it can figure out and create that that multidimensional vector space. Again, it does not have to be 3D. Indeed, it's not 3D. It's way more than 3D. Our brains cannot understand more than 3D, but computers can very easily speak in 3D, in multidimensional. Next, event number 2 was Transformers. And Transformers was introduced in 2017. So that's only like 5 years ago. And Transformers imbued feed-forward neural networks with the benefits of recurrent neural networks. And you can read more about that in this paper, which I highly recommend, which is called Attention is All You Need. What Transformers really did at the heart of it is it trained neural networks, or it allowed neural networks to take into account the sequence of words, right? So to know that bull kills man is very different in meaning than man kills bull. Transformers really imbued now these techniques with the ability to take into account sequence and take that into the ranking and the placement algorithms that they generate. This was the most significant advancement in relevance scoring that we have ever seen. So there is a score called the relevance at 1, or R at 1, that measures the relevance of these algorithms in the top position. And that technique alone led to a 27% relative jump in that score. Previously, all of our attempts to improve relevance using traditional keyword techniques and knowledge base attached to it would only increase this metric by 0.1%, maybe 0.5% if we're lucky. This was the first time ever that we saw an increase of 27% in the actual relevance of these techniques. And one of the very first products, actually, that Google built based on top of this transformer model was built by my co-founder at ZIR today, called Google Talk to Books. I recommend you go try Google Talk to Books. They indexed about 200,000 books and built this comprehension engine that understands the books at a very deep level, and you can ask very, very sophisticated questions out of these books. Like, for example, when and why did Darth Vader announce to his son that he is his father, for example? And it would still give you the right passage within the books related to that very highly sophisticated question around the book versus matching the keywords. The last significant event that took place, event number 3, was what's called unsupervised pretraining, or the paper for that is BERT, if you're familiar with BERT. And unsupervised pretraining, in a nutshell, is like us as humans. I am not a medical doctor. I don't have a medical degree. I'm a doctor in philosophy engineering, PhD in engineering, but not in medicine. But however, if I were to read a medical paper, because of my pre-training of the English language, I would still understand what it's about. Like, oh, this medical paper is about trying to find a cure for COVID, right? And I'll know a couple of paragraphs that are very relevant within the paper, but I would still not understand many of the terms that I'm not familiar with, that the doctor would understand, but I would not. And this was, how can we allow neural networks to have that same ability of being pre-trained about the language to understand and comprehend even when it sees new information that it has not seen before. And this was done by taking a lot of fill-in-the-blanks examples, like Jean bought eggs at the, or Jean blank eggs at the supermarket. And then the neural network will try to fill in the blanks. And while it's doing that, it trains itself. And this technique not only led to the neural networks now being able to understand the grammar of a language and the vocabulary of the language, but actually it now understands the pragmatics of the language, which is very interesting. So if I say Jean cooked eggs at the supermarket, that is correct grammar speaking and it's correct vocabulary speaking, but it's incorrect pragmatically. We don't cook eggs at the supermarket, we buy them at the supermarket. So now BERT allows neural networks to comprehend the pragmatics of our language as well, and not just the vocabulary and the grammar. So these were it. These were the three events that led to this massive jump in the relevance of these algorithms. Many use cases across e-commerce search, enterprise search, customer support and chatbots, compliance when you're monitoring employees and what they're saying about insider trading, etc., etc. So many applications that this technology could be applied to. Now I want to shift gears to how we use Aerospike. Aerospike really sits at the heart of what we do. So when data comes in, we ingest these documents, we segment them into sentences, paragraphs, words, etc., etc., and then we do the magic that we do, and we store both the meaning and the original text associated with that meaning in Aerospike. We continuously run what's called index optimization to optimize that index inside of Aerospike as documents get added or deleted, defragment the document space, etc., etc. So that's on the ingestion path. But then the query path, when the query comes in, the query goes first to our semantic query processor, which maps the query from words into meaning, does the matching, and then pulls the relevant information from Aerospike and displays that back to the end user. So really, Aerospike is sitting at the heart of our platform. In other words, this is how we're using Aerospike. We're using it for data retention of all the incoming data, which is more batch-oriented than latency-oriented. But we're also using it for the query serving, which is very latency-oriented and very latency-sensitive. And this is where Aerospike truly shines. We use it for the offline index rebuilding and optimization, which again is a batch process. And we use it also for administration of the quota of different customers. How much are they storing with us? How much should we build them, etc., etc. So why do we love Aerospike? It really boils down to performance. The performance of Aerospike is just way better than anything else out there. We did lots of benchmarking of Aerospike against DynamoDB, CockroachDB, and a number of other systems. And we're really seeing an order of magnitude. We saw an order of magnitude better performance, both in terms of the throughputs, but also in terms of the latency and the consistency of the latency. So if I go back to this slide, you will see I made this bold comment down here where I say Aerospike consistently delivered P99 percentile performance of less than 10 milliseconds across our data set, which again was way leaps and bounds ahead of any of the other vendors that we have tried. And by the way, these numbers are for roughly lower cost as well. Like Aerospike here, I don't want to put the actual cost, but the cost was even better than DynamoDB or CockroachDB. So that's really the benefit. It's the performance coupled with the query latency. The costs are very well defined and very easy to understand. Some of the other vendors, without bad-mouthing them, you really can't figure out how much you're paying and what you're paying for, which is very frustrating. And then last but not least, user-defined functions are one of the very, really superpowers of Aerospike that allow us to do this stuff at very high performance and still have some code running inside of Aerospike. Now I'm going to conclude with this slide, which is a couple of feature requests. I would not be a good customer if I did not take this opportunity to get the product team to hear me and the engineering team to hear me about some features we would like you to add into Aerospike. The first one is reservoir sampling, where we can run queries that are only sampling. So select star from table where 1% sample. So I only want 1% sample as part of the condition. I don't want the whole data answer to be given back, and I want that sample to be done according to a certain distribution. So that's one feature that we would really love to have from the system because of how big the different data assets we work with. And then the other one is what's called proximity lookups. So if I'm storing these different vectors meaning pointers in a multidimensional space inside of the system, it'd be nice to get some sort of ability to query by the proximity of these vectors. Like when you do the dot product between them, are they very close to each other, pointing in the same direction, or are they really pointing at opposite directions? It would be nice to have that feature as well in Aerospike. So these are kind of like 2 feature requests that I have. So in summary, to conclude my talk, at ZIR, what we do is a search engine as a service that truly finds information by the meaning you're after, as opposed to the keywords. It's way more highly relevant than the normal techniques, and it does it across any language, no matter what you're querying with, or no matter what the document is in. And then Aerospike sits at the heart of our system, and what it excels at is very high performance in terms of throughput and latency at very good cost. So with that said, I can now take some questions from the audience.
All right, Amr, that was great. As a product marketer, I think I can appreciate both the what you like about Aerospike at the end, and for messages to our product team. You know, I might think our hyperlog capabilities are pretty close to that today, and other secondary indexes and even set indexes that we've had for a little bit, again, pretty close to that second request, but well received. So thank you. So a couple questions. So let's talk about semantic search. It's been around. It's not super new. Even decades, you could say. So why are you so bullish on it now? What's changed in your opinion? I know you touched on some of the trigger points, but
yeah, very very good question. So you're right. Semantic search has been something that we've been dreaming about for decades, and many organizations and companies and researchers have tried in the past and consistently failed. And I think why is because we didn't have the technology to be able to do it. But now, because of these 3 events I shared with you, the word vectors, transformers, the unsupervised pre-training with BERT, and techniques like that, we are now, for the first time ever, able to do that. In fact, these techniques combined right now, proven, it beats humans. It beats humans at question and answering. There is many question and answering benchmarks out there, and these techniques now consistently, for the first time ever, beat humans, adult humans, in terms of how it's able to find answers for the questions. So that's why. The reason why is because now we have that technology to do it, and we never had that before.
Yeah, I mean, it makes me think of over a decade ago, I think when Watson came out, but it had to like crunch, the internet. So quite a bit different. You're a bit of an entrepreneur. Obviously, is your plan to offer this? You listed kind of applications, but I mean, is this something that could beat Google and Bing? Would you offer this as consumer search, or is that not your intent?
Yeah, so this could be done as a consumer search. Like we can take this very nice product now that does semantic search and offer it to consumers. But instead, what we have seen, there is a very big gap in the market where many organizations and companies are struggling with this. For example, when somebody comes to the Aerospike website, which I'm hoping Aerospike will be a customer, and searches your FAQ, your frequently asked questions, or searches your customer knowledge base about problems they're having with running their queries, today they're still doing keyword search and they're getting wrong answers. And these questions, when you're doing a customer support or knowledge-based search, tend to be more verbose in nature. Like I'm not just searching YouTube. When you're searching for YouTube, it's very easy. We know YouTube, here's the website, we're done. No, I'm trying to use a secondary index, and I'm finding that my performance is subpar. How can I fine-tune that? Like, that's a very verbose question. Keyword search will absolutely fail for that. Our system works for that. So that's kind of the target we're after. We're after companies that have data, and they want to enable their customers to search on that data with very high efficacy.
Yeah, I mean, I find that sometimes my searches on Google are a bit superficial. I don't want to, I kind of have something besides the top 10%, and I want to find, something a little bit deeper. I also observe, Google Mail. It kind of, I call it like lards up the results, and it doesn't understand really, why isn't it bubbling up? Why am I getting all this extra? And so it's really missing my intent of my question, which, sometimes people can misinterpret me, but I like my computer to not.
Yes, that's why I made this comment about neural link and the chips. Like even with their language, like English to English, we misunderstand each other all the time. Because again, language is simply the means to the end. There is really an idea here that you can send me the idea from your head right away. The chances of me misunderstanding you is much lower. So hopefully one day neural link will be figured out. That'd be great.
Yeah. So it's almost like, in the name of your company, it's ZIR AI, and I think of AI ML, and neural networks is kind of like the epitome of I'll say complexity, or like, and so I know ML models need to be retrained constantly. Do you need to do that with neural network models as well? Can you kind of educate us on that?
Very, very good question. So actually building these neural network models is extremely expensive. So for example, if we had to retrain that neural network model for every customer that signs up with us, we would never be able to run a healthy, profitable business because of how expensive it is to build these neural network models. And so one of the key secrets that we have as a company is we were able to build a neural network model with a technology called zero shot, with an approach called zero shot pre-training, where we train the model once on content available on the web, medical papers, news on Reddit, transcripts from movies, books that we can find. We trained on every content we can find once. And once we do that, we can now use it with a customer that might be in the health space, in the legal space, in the accounting space, in the manufacturing space, and we don't have to retrain. It's the same model that runs over and over again and just works. In the same way that, again, I said I'm not a doctor, but I can read a medical paper. I still understand the essence and do a good job at highlighting the paragraphs relative to what somebody is looking for. So that's the genius of doing this. Now, that said, I still have to retrain that overall model once every 6 months or so, because we, as a human civilization, we change what we mean by words every now and then. So Corona, 2 years ago, was a beer and chocolate. Like the first thing that comes to your mind when you say Corona, it's either the beer or the chocolate. But now, of course, the first thing that comes to your mind is COVID. So for that reason, we have to retrain the model every few months.
Yeah, or a solar spot. One of the topics that comes to mind, and this might be our final question time-wise. You talked about ingest. So one of the things that Aerospike we would contend that more data is always better. So I want you to. I'm going to merge two questions in one. So bear with me. You showed the document ingest rates, but how many data sources are you currently using with Aerospike? How does Aerospike deal with data source diversity, and can you react to that? And I noticed that you use document ingest rates. So does this mean that you are currently or planning to use our document data services, API, and JSON capabilities? Can you kind of talk about, maybe that's three questions in one, but.
Yeah, so actually I don't know the answer to the last two questions. That's to the last question, sorry, the JSON capabilities and whether we're leveraging that. My technical team would be the right one to answer that one, so I'll get back to you on that, to be very honest and blunt. But yes, I mean, we do store both numerical data, which is the vectors. The vectors are numbered in a multi-dimensional space. And then we store not the full document, but segments of the document. So as the documents come in, we segment them into certain paragraphs and sentences that are relevant to the vectors that we have come up with. And we keep both of these assets in the Aerospike. So we have textual data, which is the documents coming in as we parse them. And then we have metadata, which is the vectors and the numbers that we're storing around the stuff that we parsed.
Yeah, it almost sounds like to combine, mathematical with biological. It's almost like graph on steroids to me.
Yes. That's a good layman way to express it. Graph on steroids, yes.
All right. Well, look, I mean, this is some impressive stuff, crunching a lot of data, and I think very innovative ways to really leverage Aerospike for new technology. So it's, at the very least, very cool to have you as a customer, and I know all of Aerospike really appreciates you. So with that, I'm looking at our time. I think we'll close the session with that. So, Honor, thank you so very much.
Thank you very much for having me today. See you all. Happy May 4th.
Thanks, everyone.